Okay, hello, welcome to the channel. My name is Victor, and I'm going to be your anchor for the training. So this is part 2 of the training, the cyber threat management course. Okay, so in the last series, we've looked at governance and compliance, laws, standards, having to make sure that we have some kind of ethics. We understand some of the commandments, some of the things we should know. Understanding that for an enterprise, for a company to actually fight cybercrime, there's need for some kind of governance, for some kind of principles, for some kind of standards, for some kind of policies, right? And aside that, there is also need for compliance to regulations, to standards, to laws. So these are some of the things that make sure the company is ever ready to fight crime. Okay, so in part 2, in module 2, we're going to be looking at network security testing now. Network security testing. So we want to test our network to see how secured our network is. So the first thing is, what is a network? So a network is, you have two, right, or more computers or devices or assets or phones or whatever trying to share resources, right? So these two guys, they want to share resources. That's what they call a network. And the resources can be internet, it can be files, it can be emails, it can be anything. It can be hardware, it can be printers, it can be whatever. So sharing all of these things makes it a network. So it can be two, it can be more systems, right? And most of the times we say a network is comprised of our end devices, right? Our end devices. The end devices, you have the what was it called? You have your intermediary devices, and of course you have your connectors, right? So you have an end device, you have intermediary device, you have connectors. So these guys help you to set up a network. So your end devices are like your printers, like your mobile phones, your laptops, all of those guys are your end devices. The guys are actually trying to share resources. Then your intermediary devices are your routers, your switches, your servers. The guys in between, if I have a system here, I have another system here, most of the time I will need a switch, right? This is a PC, this is a phone, right? I might need a switch. I connect this into this port, I connect this into this port. So this is a network. So this is the end device. This is an end device also. This is a switch, so it's an intermediary device. And this is the connector. So the connector here can be cable, of course. If it was a router now, right? So you say Wi-Fi signal. So if it was a router, then is also an connector. So you can connect through Wi-Fi, through Bluetooth, through cable, through any of those connectors. So now, we're not talking about networking here. We're trying to say, how do we test our network to make sure that it is secured? Now, a prerequisite to this aspect of this course is going to be you understanding basic networking. So if you check the channel, I'm going to leave the playlist on the comment section or the description of this video, a complete series I have on CCNA1 networking. So if you're any of the students following me on this channel and you've gone through my Cisco networking course, amazing series from Cisco, you should be able to follow up now because you understand end devices, connecting media, routers, switches, protocols, firewalls, intrusion detection system, intrusion prevention systems. You understand all of those basic things. Now we're trying to say, how do we test that network? So if you are new to networking, you can check the channel, go through those items, then you come back to this section of the training. Now let's look at vulnerability scanners. So we're trying to say, if we want to scan our network to see if it is secured, one of the first things we want to do is to do some vulnerability scan. And what is vulnerability assessment, or what is something being vulnerable? Here we're trying to say, once there's an anomaly, once something does not follow standard, once there's a loophole, once there's a flaw, we call that what? A vulnerability. So what a vulnerability scanner, a vulnerability software, a vulnerability hardware, a vulnerability application, what it does is to do what? Is to check if the computer systems, the network, right? The computer systems, the applications, your cloud applications, if they are what? If they have vulnerabilities, if they have loopholes, right? So what are some of the types of vulnerabilities that we can have? We can have missing patches. Patches is just like when you have a clothes, right? And you have a hole here. What do? You patch it up. You patch it up, right? So if you have loopholes and there are no patches for it, it constitutes vulnerability. If people are using common passwords, some devices, okay, let us see something. Let us see something common, or let's use routers, for instance. Router default logins. So you see there are quite a lot of sites that have most of these default logins for routers, right? What is my IP? You might be using a Netgear router. So you say top brands of routers. So you have quite a lot of routers. You have Huawei, you have TP-Link, you have ASUS, you have Netgear, you have Google, you have Synology, you have quite a lot of routers. So we're saying for these routers, when you buy them, they come with default passwords. Yes. Default password router. Let me look for an image that tells that. This is another default. When you buy your Verizon, when you buy your MTN, your BATI, your Airtel, when you buy those routers, when you buy those devices, right, for your connectivity, they come with defaults, right? This is the Wi-Fi you're going to see. Linksys, just like your phone, when you buy your phone, the phone is going to have maybe iPhone this, or it's going to have Techno this, or it's going to have HTC this. The default name of your phone, of your phone's Wi-Fi, is going to be there, the username and the password, right? Some will just have passwords, the name and the password. So if you buy this Linksys router now, this is going to be the name that you're going to see once you switch it on. This is going to be the default password. If you see this router, right, this is going to be the name. This is going to be the what? The default password. If you want to access it through your browser, this is going to be the default. This is going to be the IP you're going to put in your browser. This is going to be the username. This is going to be the password. Look at this one. So this one is 192.168.0.1. Default username is what? Admin. Password is what? Admin. This one, right? Default router login is routerlogin.net admin password. So we're trying to say this is for a Netgear router. So we're trying to say that once you use default passwords for those your devices, your web applications, you are being vulnerable, right? So another thing is if you have open ports, right? So this is networking now. So in networking, there's what we call port numbers. So ports are numbers for protocols that are being used for communication. If I have system A, system B, we want to do video connection, right? So this is the line. So this is a protocol. Protocol just tells us, okay, how do we communicate? We say, okay, through this line, enter, want to send video. So this line is going to have a number. So it can be, let's say, 5. Because okay, if we want to communicate via voice, this is the root. This is the access route for voice. What's the number? 6. Because okay, we want to connect, we want to communicate via, we want to send a Wi-Fi signal. Where is the road? Where's the route? So this is the protocol. So what's the port? This is 10. So the port is a number, the protocol. So you have things like HTTP, right? That's the protocol. The port is what? 80. You have DNS, that is the protocol domain name server. What's the port number? 53. You have SSH or SSL. What's the protocol? That's what I just mentioned. Secret socket layer or SSH. There you have what? 443. Once you have HTTPS, same thing applies. Once you have FTP, file transfer protocol, what's the port number? You have, what's it called? You have 21. SFTP, you have 22. SNMP, that way. So if you have different port numbers, so you could see top 10 ports, protocols, and port numbers, right? So with your basic networking, you should know this is port, this is FTP is 21, 20 or 21, depending on how the data is moving. IMAP, this is for email, is 143 if you're configuring your Outlook or thereabouts. So all of these are different protocols. So if your protocols, the port numbers are open, it can be a vulnerability. Because that port number being open tells us that that is how that line of communication is open. And if a line of communication is open, unattended to, and you are going to be the one that is going to be using the line of communication, you're not going to be the one using the line of communication, that means that a hacker can actually use that line and perpetrate anything. When you misconfigure your operating system, right? You have active IP addresses, including unexpected devices connected. So this is simply principle of least privilege. So vulnerability scanning is going to be very key in identifying these vulnerabilities, misconfiguration, lack of security control. So that's what you do in vulnerability scanning. So in our labs, in our hands-on, we're going to be using, let me see the labs we're going to be doing with respect to vulnerability scanning. So we're going to be doing this lab. We're going to also be doing this lab. We're going to be doing, I think we're going to be doing this Wireshark also. We're going to be doing quite a lot of these labs that are associated with vulnerability assessment, right? CV is common vulnerability and exploits. So very crucial, you need to understand, we're trying to lay the foundation. So we're trying to say that vulnerability scanner is going to check if your systems, your networks are vulnerable or not. Now, there are quite a lot of vulnerability scanners. So you have OWASP Zap, you have Nessus, you have Retina, you have CoinPact, you have GFI Langard, you have quite a lot of them. What they do compliance auditing. So if by your compliance check or regulation, take for instance, you're trying to comply to PCI DSS, Payment Card Industry Regulation, or you're trying to comply to GDPR, General Data Protection Regulation, or you're trying to comply to, let's say, any of the ISO standards, or you're trying to comply to NIST framework, that is NIST. So what we're trying to say is that by you running your vulnerability assessment scanner, they help you to check if you are following those standards. So that's why we're saying it's going to help us for compliance auditing. It will help us to provide patches and updates. It helps us to see if there are misconfigurations. It helps us to track a malware. It also to identify if they are sensitive data. So we're going to be running most of these scans. So there are different types of scans. So it can be a network. You can be trying to scan a network scan. You could use Nmap to do that, or Zenmap, the GUI version. You can be using Wireshark application. You can be using SQL Map. to do vulnerability assessment. You can be using OWASP Zap to do vulnerability assessment. We're going to do most of these things in our hands-on lab, right? So web application scanner, so of course, it's going to now scan for applications. Now, there's what we call intrusive and credential scan. So I want to differentiate them. So intrusive scan is going to exploit vulnerability by, that may even crash a target. Now, so this is also what we call an active scan. So an active scan is going to attempt to try to scan the system, to scan the application, whatever the case may be. So, but a less intrusive scan is not going to actually try to break the system, right? So another concept is credential scan. So when you do a credential scan, you're trying to say that you have the username, you have the password. So most of the times in an ethical environment where you are being contracted, when you are being told to scan, to test, to check for vulnerabilities of a system, you might also want to test the vulnerability of the system. So you already have the logins. So you want to check and see how much information can you harvest. Okay. So for a network scan, for instance, so Windows have quite a lot of utilities. So I think in one of our classes and in one of the labs, we talked about different scans. So we have IP config. So this is going to display the TCP IP settings. You have ping, you have ARP, you have TreSAT, you have NS lookup, you have NetStart. Let me run some of these ones, or I will reserve them for the lab sessions. So because I want to use this opportunity to lay most of the foundation so that we run through most of the labs together in sequence. So if you open your CMD and you run an IP config, it's going to tell you what? It's going to tell you what your IP address is. It's going to tell you what your default gateway is. It's going to tell you the DNS you're connected to. It's going to tell you your MAC. At times we call it your physical address. A ping scan is going to tell you if you are connected to that particular asset. It can be a website, it can be an IP address. So this is a type of scan. So that's why you call them diagnostics. You want to check, can you actually see the other end of the server? Can you actually connect? If you do ping soutechventures.com, the response is going to tell you if that website is up and running or not. If you say ping 192.168.8.1, you're trying to check, is that IP address up and running? So you're going to see if the route or the host is available. So it's an ICMP request, Internet Control Messaging Protocol. So it just tests for what? Connectivity. Of course, ARP, Address Resolution Protocol, Address Resolution Protocol. Sorry if I'm fast. You can reduce the speed of the video so that you can catch most of my explanation. So ARP is Address Resolution Protocol. So that works together with DHCP to assign IP addresses to devices on your network. So it keeps a table, right, which is the MAC address and the IP address. Let me show you this so that you kind of see what it looks like. You have your CMD. So if you say ARP-A, right, it keeps a table of the IP address and the MAC address. That's why you call this your physical address, right? Then ping, this is going to tell you, okay, I have this system. If it returns 0% loss, that means that this is up and running. But if I say, for instance, ping 192.168 this, right? Just a random stuff, I cannot find it. So that means that this is done or this is unavailable, right? TreSAT is going to check, okay, how many routes do I have between my system, this is my system now, and this particular server. Before running this, let me run ipconfig. So ipconfig is going to give you a summary details about your connectivity. So it's going to say, okay, this is your IP address. This is it here. This is your gateway, and this is the subnet max, right? So if you say ipconfig/all, it's going to tell you all of the different adapters you have connected on the system. This is the host. I have one connector 2 adapters, second connector, 3. I have 3 adapters on this system. So, but this is what I'm currently using now. And you see, it can tell me, okay, this is my server, and this is my own IP address. So the DHCP enabled, yes. So this is the physical address. It gives more details, even tells the name of the Wi-Fi card, right? So you can try that, do the same thing for yourself. NetStart. So it just gives connections that are connected and connections that are not connected, the ones that are established, the ones that are idle, the one that. So when we do digital forensics, there are better tools that you can use to do some of these things, but these commands on the, what's it called? On your CMD gives you some kind of idea about what is actually happening under the hood in your system. So this IP address, these are loop back IP addresses. They are established. This is the system, my system. So this is my system here also. This is my IP address going to these IP addresses, right? I can start investigating each of these IP address. This is even an EC2 instance. This should be an AWS server. So you see these connections are established. So under the hood, you can see what is happening on this particular system, the connection it's making out of the network. If you use a tool like TCP View, it's part of the sysinternals tools. Sysinternals tool is a former Microsoft employee that created that worked on some applications. It has quite a lot of tools inside of it. During digital forensic hands-on lab, we're going to explore some of them. Very awesome tools. Now, it will give you a more robust view of what you are seeing in NetStart. Okay, so you have some of them: ipconfig, ping, ARP, traceout, NSLOOKUP, NetStart, right? I didn't do the traceout again. So the traceout will just tell you how many hops you have between your system and the server. So these are basic command line diagnostics tool. Or you'll have NetStart, NBitStart, Network Basic Input Output System, Nmap. Nmap is a tool also. We're going to be using this in Kali. You can also use the what's it called? The GUI interface called ZenMap, right? Then of course Netcard, HPing. So all of these are tools you can use to do network discovery. You can use to do network diagnostics, to do your network diagnostics. So let us look at security automation. Now, if we want to find a way, you see, to do most of these things is all manual process. What about if we want a solution whereby we can have an information and event management system that is going to aggregate a tool like SolarWinds, Splunk, like a tool from IBM? You have quite a lot of tools that you can actually use to aggregate most of this data into a more robust interface, so that even aside using my auto run checker, my system monitor, these are tools we're going to do in the channel. Sometime in the next 2-3 months, I'm going to be releasing a series on SOC tools. So because this is a SOC tool, right? So because a SOC tool is a security operations center tool that is going to help you, instead of running most of these things manually, you now have it in a very robust format. Windows also have its own event management tool, but what a SEM does for you is that it makes it very simplistic. It aggregates everything together. A very popular one is Splunk. You also have SolarWinds, and you have quite a lot of others. Then for a SOA will help you do what? To respond. So you can use the SEM to actually put everything together so that you can tell what is happening within your enterprise. So it's going to have what we call log collectors. It's going to have a way to collect data, and these data are called events. If you have a spike in traffic, you want to have traffic, you want to know how many logins, you want to know the software is installed, you want to know all of those activities that happen within your enterprise, within your system. You want to be able to monitor them. And that's why it's called SEM. You want to check information. You want to also know the events that are happening, then you want to manage them. So monitor activities, conduct compliance reporting for audit. So because if you know what is happening, you could understand if you're actually complying with some of these standards and some of these regulations. So when a system detects a potential issue, it might log additional information, generate an alert, or instruct other security controls to stop an active process, right? Then you also have, okay, same. So you have SOM, I've explained SOM. So what a SOM is, a SOA is going to do is going to now respond. So this doesn't just collect, it can actually help you to what? To respond. Now, this is synonymous to the comparison between an IDS and an IPS. An IDS is intrusion detection system, which can be a software, which can be a hardware. Then you could just check up intrusion detection system, right? Hardware. So you have quite a lot by different vendors. Some of them cost a fortune. You have Imperva, you have them, some of them have hardware, some of them are softwares, right? Range from $2,000, $3,000, $4,000. You can implement them. You also have them as software. So they act like firewall. They act as a way to actually detect, to like be a bridge between you and your network to see what is happening. And some of them would detect and log. Whereas an IPS is not going to do what to prevent that eventuality. IDS versus IPS. So that is the core difference between an IPS and an IDS. So an IDS will provide an alert. An IPS will do what? Will take action to block an attempted intrusion. And IPS is always very intrusive, right? And it's going to take a lot of bandwidth. Checkpoint, Imperva, you have quite a lot of vendors that have IPS softwares, IDS, also RDS hardware. Okay, so we have some network security testing techniques. Let me see if we have some labs that are going to cover some of these aspects in the training. Okay, I think this is going to be part of the first module, security measures to meet compliance requirements. Because at times you want to make sure that you can actually meet your requirements. Your requirements might be HIPAA, your requirement might be NIST, your requirement might be PCI, your requirement can be anything, right? So we're going to treat, like I said, we're going to treat these labs separately and dive into them in core detail so that when you are trying to do vulnerability assessment, most of the times your vulnerability assessment are going to be tied to maybe the compliance they are trying to meet, governance principles and plans, or you want to meet your policies. Maybe your policy says you should do vulnerability assessment every 6 months. So there's always going to be a reason why you are doing your vulnerability assessment. Or you just recovered from a hack, then you're trying to run some vulnerability assessment to see if there are still some indicators of compromise, which we now call threat hunting. So that's the difference between a vulnerability assessment and threat hunting. So you want to now do some threat hunting to see if you still have some things that already happened that you weren't aware of, right? So there's always going to be a reason why you are doing some of these tests. So, operation security is concerned with the day-to-day practice necessary to first deploy and maintain a secure system, right? So it's very important. You want to implement process of a network. You want to the operation team will analyze the designs. You identify risks and vulnerabilities. Then you make some necessary adaptation. In this course, we're also going to learn how to do risk assessment. We're going to learn how to do quantitative risk assessment and qualitative risk assessment. Risks, right? Risk analysis, right? Risk management. So we'll learn how to create a risk plan for an enterprise, right? Very crucial. And also how to do quantitative risks. Because most of the times in risks, we are saying for us to mitigate any risks. We must make sure that we are spending the right amount of money. We don't want to overspend. So a risk analysis will tell the possible vulnerability and threats, their likelihood, and of course the consequences. So our spending, to know how much we're going to spend on the risks, we want to check things like annual loss expectancy. We want to check what are we going to lose if we don't implement such kind of risk. So there must be some quantitative risk analysis to check what is the best logical approach to mitigate such kind of risks. Okay. So there are some techniques here. So some security testing techniques, predominantly manual. So in doing your security testing, you could do manual. You could also do a kind of an automated testing, right? So you could be doing some of the things you should be knowledgeable about. You should know how to use your operating system, Mac, Linux, Windows, right? Basic programming, HTML, some PHP, some Python, some of these basics, right? On the channel, I have a complete series in web programming, where I did Bootstrap, PHP, WordPress, HTML. I was going to start the Python series soon. So, because some of these things will help you understand how to do your testing. In the internship program also, we are going to be creating tools, right? I think, let me see if I can grab that. Just a second. So some of the projects for the internship is some of these tools that we're going to be creating. We're going to learn some basic PHP, some basic Python. The goal is that we want to be able to use these learnings to create some web OSINT, open source intelligence gathering, some network scanning. Because yes, you could use PHP, you could use Python to like scan a network and automate the process. You could create a tool by yourself. You could also use free tools or open source tools. So your basic learning of programming and scripting will help you to be able to create some mini applications, right? You could deploy your enterprise, or you could use free applications, or you could use paid enterprise suites. So some of these skill sets are very crucial, like networking, device hardening, firewalls, and IPS. Okay, so it's very important that you should have a standard, a policy, right, on when and how to test and evaluate your network. Because if you have a flow, if you have a policy, if you have a plan already developed, it's going to inform you on how, when, who is going to be responsible for most of these tests. Okay, so we'll cover some of these things in our information security policy document, where we create these plans ourselves, and that's going to tell us how we're going to do that. Very crucial, very important. Let us differentiate penetration testing, network scanning, vulnerability scanning. Okay, now, the thing is, if you want to do penetration testing, it starts from a security audit. Right? So a security audit, at times, a security audit, you're trying to see if you are following some standards. And at times, you just want to check an inventory, you want to get an inventory of what you have on ground. Take, for instance, if you don't have a web server on ground, should you be doing a web penetration testing? No. If you don't have a network, should you be doing a network penetration testing? No. So in a security audit, you want to check what you have on ground. You want to see how many nodes you have, what kind of network you have. You want to have the architecture. You want to know the topology for your, what is it called? For your, if it's a web application, you want to know how is it built. In the channel, I have a series where I looked at how, and I showcased practically how a website that was hacked was fixed. Contact the channel. I will say how to drop the description also. You have a series that shows how to fix a hacked website. Now, a website that is already hacked, for you to fix it, you first need to understand how the website was built. because that is the very first basics. So in an audit, you want to see what you have on ground, just like accountants we do to check if you are following regulation standards. So that is what an audit is. So a vulnerability scanning, a vulnerability assessment is now going to check whether there are loopholes, whether there are potential weaknesses, whether there are misconfigurations, right? Whether there are some kind of misconfigurations. Sorry. Whether there's some kind of misconfiguration you have, whether you have some blank or default password, whether there are some potentials for a denial of service attack. You want to check all of those things. Then in penetration testing, because there might be a loophole or a misconfiguration, but it might be intentional, right? Because you now have a secondary fix for that vulnerability. Take a classical example where you have a router and the password is open. But even that the password is open does not mean that it is vulnerable. What we did was to leave it open, then but we have a captive portal, right? You see this in hotel, you see this in banks, you see this in some offices or for some enterprise. So if you come into the network, the router is open, you just leave it open, then but you will need to now enter the username and password given to you by the administrator, right? So you are told, and so you open your browser, you want to browse, thinking you have access, and you are told to enter your username and password. So you have it in most hotels, in most organizations, in most banks. You have something like a captive portal that will just ask you, okay, please enter your username, enter your password. If you visit a hotel, they give you a complimentary Wi-Fi access, and getting to the Wi-Fi, you won't be asked for password, but if you open your browser and you want to try to do any browsing, you're going to find out that it's going to tell you to please enter your username and password that is being assigned to you. So that the router that you got access to was open does not mean that you have a loophole. There is a captive portal at the other end. Another example is that you have a software that is a legacy software. Or let's say you have a Windows that is Windows 10 or Windows, let's say Windows 8, and we built a software for that particular version of Windows. And the developers couldn't, there was no opportunity or there's no budget for us to upgrade. You have this in most ATM machines. Most ATM machines still use lower versions of Windows. Most ATM machines have not started using Windows 11. So a vulnerability is, we now say, okay, there's a loophole, there's some vulnerabilities associated with this particular version of Windows you are using. So in penetration testing, what we're trying to now say is that we want to now try to attack to see if the vulnerabilities that we found that are susceptible to a hack, right? So there are several ways to do penetration testing. So you can be trying to run an application, you can be trying to escalate privilege, you can be trying to, this is actually beyond the scope of this course. So this is just to explain to you some of the different types of tests you can carry out. In the internship, in the ethical hacker labs that we have, we explore most of these hands-on labs, right? We're going to be doing social engineering, doing Wi-Fi hacking, doing web hacking, doing all of those kind of stuff. So, but here I'm just trying to explain to you the different type of tests that you can have. Okay, so you have password cracking, log review, integrity checker. For integrity checker, for instance, you're trying to see if there is a change in the system. You see, every file is going to have a hash value, right? So a hash value just like a signature for a particular file. So if you have this file and you won't add a full stop to it, the hash value is going to change. Okay, let's see if we can demonstrate that. Hash file. Let's say hash file. Let me see if I can see a site that can Okay, let me just use VirusTotal to achieve this, VirusTotal. And it can serve two purposes. It can serve the purpose of also virus detection. So I'm going to make a file. Look at this file now. The name of the file is mailtrack.io. This is just a notepad I have here. Let me save it. I'm going to save it in my desktop, right? Save, right? It's saved as https mailtrack.io.txt, right? So I have this file now. Okay. So let me load VirusTotal. I want to upload this file and get the hash value. Then I will tamper with this file by adding just a full stop, and I will try to generate the hash. Once it differs, it then means that integrity has been compromised. So even in the military, this applies, because if you have a document, if you have a list and it's been tampered with, you could check across the chain of custody, across the different places where these files move. You want to be checking the hash value consistently to be making sure that nothing is tampered with. Because if you scan through the document, it might be difficult for you to see if a text, a word, something was tampered with. What's happening? VirusTotal. Okay, so we have VirusTotal. I don't know, will it be my internet not loading? Okay, so VirusTotal can help us do virus detection. It can help us do integrity check also. I'm sure I have issues with my internet. Okay, let me see. Test results. Okay, so understand that you have to actually have your test results and see how they serve as benchmarks, how they serve as tools for you to plan, tools for you to implement your security measure, tools for you to actually conduct future testing. So in the lab session, we're going to be looking at quite some of these labs in network security testing. So in part 3, we are going to be looking at threat intelligence. Very crucial, very important in threat management. Thank you very much, and see you in the next series.